All right, you guys, we're going to go ahead and demonstrate the Ocean Currents and Climate Lab for you guys. So we're going to go ahead and start, and I'm going to do these sequence of steps for you guys. You're going to fill each baby food, and if you have baby food jars at home and salt and food coloring, you're more than welcome to do this on your own. You go ahead and you fill them each about halfway full.
If you don't have the materials, that's why we're doing the lab right now, and you can just respond. But if you do, it'll be extra credit. Send us a picture.
All right. So fresh water is going to be your red food coloring. Your salt water is going to be blue. Think about when you go to the ocean and there's a lot of salt water, it's very blue. That's just one way to remember it. So right now I just have water and food coloring in each of them, but the one that is salt water, we are going to go ahead and add about 10 grams of salt. Oh, that was a little extra. That's okay, we'll just lighten it up. And then we're going to stir those.
Remember, the ocean is blue, and oceans are salty. They have a high salinity.
And then, we're going to go ahead and top off these baby food jars all the way to the tippy top with water.
Notice how the water actually bubbles. That's from the surface tension of the water molecules. They bulge over the top. They have such a high bond.
Then what we're going to do is we're going to see, if you guys go to page 4, it asks you guys to put a salt water over the fresh water and to see what happens. So salt water over fresh water. So we're going to put a blue jar over a red jar. To do that, we are going to take an index card, set it on top of the blue jar, flip it over, set that on top of the other jar, and pull. Notice how they mix. It's now a perfect purple color throughout the entire jar, and you're kind of wondering why. So your salt water has a higher density because of all of the salt inside of it. So when we superimpose the salt water on top of the fresh water, because it was more dense than the less dense fresh water, the salt water went into the fresh water because of density and mixed, creating an equal concentration of the colors throughout the jars. So what you're going to do here, it says to predict what you thought would have happened. So what did you think was going to happen, and then what actually happened. So now we're going to go ahead and put the fresh water over the salt water. I'm going to give you about 10 seconds. Try to predict what you think is going to happen this next time. So just go ahead and pause the video. And what do you think is going to happen when we put a fresh water on top of the salt water?
And the whole idea is that you're coloring these to determine what you think they'll be. If for some reason you don't have a red and a blue and a purple color, just write the words.
So we're going to go ahead and do that. We're now going to put the index card over our fresh water, put that upside down on top of our salt water.
So what do you think's going to happen?
There we go, and
ha!
Look.
What up, Mrs. Ammon?
So, because we have our less dense fresh water, it is going to sit perfectly on top of your guys' salt water. Now,
America.
Now you're going to go ahead and you're going to fill in what actually happened on that second part. And then go ahead and pause that until you're done. When you are done, we're going to go ahead and we're going to see what happens when you take the salt and fresh water, the first one we did, and you turn it horizontal. So do you think that the colors are going to stay mixed, that they're going to unmix, that what color is going to go on top and what color is going to go on the bottom? So go ahead and color in your predictions. Pause the video until that is done. And now we're going to go ahead and show you. So if I go ahead and I take these jars and I slowly turn them sideways, notice that the color has remained the exact same. And if I go ahead and turn it all the way upside down, it still is that exact same purple color. It did not go ahead and unmix itself once it's been mixed and created that solution. It's not going to unmix itself. So go ahead and go to your paper, draw that it is still completely purple. And then we're going to think about this one right here, the one that is red still on top and blue on the bottom. What's going to happen when I turn that horizontally sideways? So go ahead and draw on your last picture here what you think is going to happen, and pause the video until you're done. And then we're going to go ahead and we're going to demonstrate to you guys what will happen. So if I take these jars and I slowly move them sideways.
Whoa. It looks like a lava lamp. Holy camole!
And notice how they stayed completely separated. So because there was never the pressure of the density of the salt water to fall into the fresh water and force it to mix, that fresh water is able to float perfectly on top of the salt water due to the less density.
That's cool.
All right, draw that last picture. Using that information, please fill out the conclusion. Egan, anything you'd like to add?
Nope, but it looks like you have 3 analysis questions, actually 5 analysis questions, and then you're going to apply this to agriculture. You might have to look at what an estuary is, look that up before you respond in paragraph form. Remember, if you will not be able to write directly on this paper on the computer, but you can print it off, or you can use a separate sheet of paper and do all the answers on a separate sheet of paper and either upload it as an email or on Teams or text it to us. Thanks.
Until next time, see you guys.
Bye.